The discovery of life beyond Earth narration begins in the vast and silent fabric of our galaxy, a galaxy filled with frozen gas giants, lifeless rocky terrains, and a darkness stretching far beyond imagination. There is one world that refuses to be ordinary. One planet that dares to challenge our assumptions. Its name is K2-18B. Orbiting a cool red dwarf star, over 110 light-years away in the constellation Leo, K2-18b was once just another data point, a speck of possibility in a sea of numbers. But then, something happened. Something extraordinary. For years, astronomers noticed unusual readings. First, there were signs of water vapor in its atmosphere. Then, subtle traces of carbon-based molecules emerged. But in 2025, everything changed. With the help of the James Webb Space Telescope, we looked deeper, clearer than ever before. And what we saw was not just chemistry. It was the whispers of life. What makes K2-18b special? K2-18b isn't like any planet we've studied before. It belongs to a rare class called Hycean worlds, a fusion of hydrogen-rich gas giants and ocean-covered Earth-like planets. Its size alone is remarkable. Roughly 2.6 times larger than Earth in radius, and over 8 times more massive. Yet, despite its scale and distance, it sits in the habitable zone, that delicate orbital range where temperatures could allow liquid water to exist on the surface. And water is the one universal ingredient that life, as we know it, depends on. But K2-18b isn't just wet. It may be wrapped in a dense hydrogen-rich atmosphere, trapping heat, regulating temperature, and creating an environment where oceans might remain liquid even under the faint glow of a red dwarf sun. That atmosphere acts like a cosmic greenhouse, keeping conditions surprisingly mild, and protecting its surface from deadly radiation. The chemistry that changes everything. The James Webb Telescope's powerful spectrometers revealed something stunning. Not only did we detect water vapor in the atmosphere, we also found significant traces of methane and carbon dioxide. These aren't just random gases. They're the chemical signatures of potential biological activity. On Earth, these molecules often appear together in places teeming with life: oceans, wetlands, and even the upper atmosphere. But it was what came next that shook the scientific world. Dimethyl sulfide. A potential sign of life. In 2025, Webb's mid-infrared instrument, MIRI, scanned K2-18b with even greater precision. And it found a molecule that no one expected to see. Dimethyl sulfide. Or DMS. On Earth, DMS is a molecule produced almost exclusively by living organisms. More specifically by marine phytoplankton. Tiny, floating microorganisms in Earth's oceans that play a vital role in our planet's climate and biosphere. The presence of DMS on K2-18b is like finding a fossil of a fish on Mars. It's a clue that nature has written a familiar story on an alien canvas. But that wasn't the only signature. Another molecule was found, dimethyl disulfide, or DMDS, a more complex compound also tied to microbial activity in our own oceans. Two bioindicators appearing together in a hydrogen-rich, water-bearing world. This is no longer a coincidence. This is a pattern, one that scientists can't ignore. The scientific reaction: researchers across the globe are still analyzing the data. But the excitement is palpable. Cambridge astrophysicist Niku Madhusudan, who has led multiple studies on exoplanet atmospheres, stated that these findings are statistically significant and that K2-18b may indeed be home to alien microorganisms. This isn't speculative clickbait. This is data-driven, peer-reviewed, and cautiously revolutionary. We've spent decades searching for signs of life beyond Earth. And now, it might be floating in the skies of a distant, hidden ocean. What kind of life might exist? If DMS is truly being generated by living creatures, then the most likely explanation is simple but profound. Microscopic ocean life. Tiny organisms, drifting in the vast alien seas of K2-18b, harvesting the dim red light from their sun, using a form of alien photosynthesis to survive. Just like early life on Earth. But some scientists imagine a more diverse biosphere with filter-feeding organisms drifting through layers of water, or even low-gravity aquatic flyers lifeforms that glide between ocean and atmosphere. K2-18b may not look like modern Earth. But it may mirror the early Earth, a planet just waking up to life. And now, with every new observation, we're watching a narration resume. So now we ask a question that echoes across the stars. If K2-18b truly hosts life, should we try to speak? To speak or stay silent? Some scientists say no. Physicist Mark Buchanan warns that reaching out could expose Earth to civilizations we don't understand, possibly far beyond us in technology or intent. Others argue that we may harm them instead. Dr. Anthony Milligan, a space ethicist, believes we have a moral duty to protect alien biospheres. K2-18b's life, if it exists, evolved for billions of years untouched by us. Even observation has consequences. Then there are voices like Avi Loeb, who say if intelligent life exists, it likely already knows we're here. Earth's been broadcasting signals for over a century. They may already be listening. But even if we choose to send a message, it won't be quick. A signal would take 120 years to reach K2-18b, and another 120 years for any reply. This is no short conversation. It's a message we'd send not for ourselves but for the future. A new era of exploration. While the contact debate unfolds, scientists are shifting focus to observation. NASA's upcoming missions like LUVOIR and HABEX aim to analyze exoplanets in extreme detail. Europe and China are planning their own deep space telescopes. Meanwhile, the Breakthrough Starshot initiative proposes sending microscopic laser-propelled probes at 20% the speed of light, reaching K2-18b in just 500 years. A long journey by human standards, but on the cosmic scale we're knocking on the door. The ocean world. If those future missions reach K2-18b, what will they find? Possibly a world of endless ocean, cloud-shrouded, warm, and alive. The planet might be home to simple, drifting microbes using red starlight to photosynthesize, just like early life on Earth. Or perhaps more complex organisms have evolved. Alien filter feeders. Gliders adapted to low gravity and thick atmospheres. A planet not like Earth today, but like Earth billions of years ago when life was just beginning to stir. Culture reacts as these discoveries spread. The cultural impact is growing. Some religious leaders see this as confirmation that life is woven into the fabric of the universe. Others respond with hesitation. Is humanity ready to confront the idea that we're not alone? Meanwhile, social media trends erupt. Hashtag K218 alive, hashtag ocean world, hashtag are we alone. Movies are being scripted. Documentaries are in production. The world is paying attention. And quietly, something is changing. We are beginning to see ourselves not as solitary creatures, but as participants in a much bigger story. Planetary protection. Amid the excitement, caution rises. Scientists like Dr. Monica Vidari are calling for new protections. Exoplanets with signs of life, like K2-18b, should be treated as cosmic sanctuaries. No probes. No landers. No contamination. Because even if that ocean teems only with microbes, it may still be the first extraterrestrial life we've ever found. And we must learn to listen before we act. A mirror, not a stranger. Perhaps the most profound truth about K2-18b is this. It doesn't just point to alien life, it reminds us of our own beginnings. Billions of years ago, Earth was much like it, a watery world, cradling simple life in its oceans. To study K2-18b is to look into a cosmic mirror, a glimpse at what we once were and what life, anywhere, might become. The question has changed. For decades, we asked, are we alone? But with water vapor, methane, carbon dioxide, and now dimethyl sulfide, the answer is shifting. We are standing at the edge of confirmation. K2-18b may be the first. But it will not be the last. There are thousands of ocean worlds out there, waiting to be seen. Studied. Understood. Final reflection and call to action. So now we ask you. Do you believe K2-18B harbors life? Should we reach out or remain careful observers? And if this really is the moment we learn we're not alone, what will humanity become next? Tell us in the comments. And if this journey moved you, subscribe, turn on notifications, and share this video with someone who still stares at the stars and wonders. Because the universe may be vast, but tonight feels just a little smaller.